talk about atomic structure, nuclide notation, and isotopes. So the first thing you think about when you think of an atom is maybe a picture like this, right? Where you have the protons, which are positive, the electrons, which are negative, and the neutrons, which have no charge, right? And the protons and the neutrons are in the center, and the electrons are in these orbits outside. Now that's kind of an elementary kind of school drawing. The electrons aren't actually arranged this way, so that's something that you should know, even though this is a biology class. But you do need to know that the protons and the neutrons form the nucleus in the center of the atom. The electrons are actually found in the electron cloud, so there's a region of probability. The electrons tend to be in an area close to the nucleus, but that probability decreases as you go further and further from the nucleus. And there's regions of probability, which you may have learned in chemistry class, you may not have, and that's okay. So, but you do need to know that, you should know that electrons aren't found in specific orbits like planets around the sun. They're found in these regions of probability, and these are actually called orbitals. But again, that's not important for this class. So next we're going to talk about how do you write the notation for atoms, and this is called Nuclide Notation. So first we're going to look at our periodic table. I'm going to pull it up here. So you took chemistry already, so you realize that you know some of these relationships, and you've read and you've looked at this periodic table before. So let's take a look at carbon, which is atomic number 6. If you have the symbol carbon, right, and then the number on the bottom is the atomic number. And the number on the top is the mass number. The mass number is equal to the protons plus the neutrons. So that means that if the 6, right, the atomic number is the same as the number of protons, and we know that the mass number is 13, we know that the neutrons are 7. So basically you're subtracting the atomic number from the mass number to get the number of neutrons that are in the nucleus. The number here in the top right-hand corner is the charge. So in this example, there is no charge. So the number of protons and electrons are equal. If the charge is positive, there's more protons. If the charge is negative, there are more electrons. So let's look at such an example. Let's take fluorine minus, and we'll say that the mass is 20. We don't need to write the atomic number down because fluorine has a certain number of protons. All fluorines have, you see on this table, it has 9 protons. So we can say that the protons are 9. The neutrons, right, it's 20 minus 9, which is 11. And the electrons, since there's one more electron, right, this number is negative, so it's -1. It has one more electron than protons, so it has to be 10. So that's how you write nuclide notation. It allows you to show in a written form how many protons, neutrons, and electrons an atom has. Next, we're going to talk about what isotopes are. So isotopes are atoms with the same number of protons but different numbers of neutrons. So if the number of neutrons is different, that means the mass is going to change. So remember on the last slide, 2 slides ago, the mass number is the protons plus the neutrons. So if the neutrons are different, that means the mass number has to be different, but the number of protons is the same. So example, carbon, all carbons have 6 protons. So I'm going to draw 3 carbon atoms here. But some carbon atoms have a mass number of 12, some of them have 13, and some of them are 14. What this means is that this atom has 6 neutrons, this atom has 7 neutrons, and this atom has 8 neutrons. Now, if you look at the periodic table, the mass of carbon is 12.01. What this means is if you take a representative sample of carbon atoms and you average them according to how often they show up, their percent abundance, you can find out the average mass. So what this means is that most of the carbon isotopes have a mass of 12. There's a few of them that have a greater mass than 12, it appears, from this average. Okay? So you will have to know, as the last part of this video, how to calculate the average atomic mass of an atom. So let's take a look at an example. If carbon 12 and carbon 13 and carbon 14 are the predominant isotopes of carbon, and then you say that 90% of them are carbon 12, you say that 9% of them are carbon 13 and 1% of them are carbon 14, then you can calculate the atomic mass. Again, these are just numbers I just made up, but this is how you would do the calculation to figure out what the average atomic mass is of carbon overall. So to do math with it, you would need to do 0.90, right, to turn 90% into a percentage, and you multiply by 12, right? That's the mass number. Now, the units would be atomic mass units. Then you do the same thing for the carbon 13, 0.09 times 13 AMUs. Right? Remember that protons and neutrons weigh a similar amount, basically 1 atomic mass unit, and electrons weigh nothing, essentially. They weigh about 2,000 times less than a proton and a neutron, so we just ignore them. And then you would plug that into a calculator, and you would get the average atomic mass of carbon. So if you have any questions, please write them down, and I will be able to answer them in class tomorrow. Thanks.